Hello viewers and learners wherever you are, welcome. Today we are going to look at arithmetic series. Last time we looked at arithmetic progression, we also looked at geometric progression. So today we are going to look at arithmetic series, in that when you are given some terms in an arithmetic sequence, what do the sum of those terms in an arithmetic sequence yield to? So you are going to find or to derive a formula that you are going to use to carry out sums of terms in an arithmetic sequence. Now, in arithmetic sequence, given an arithmetic sequence where the first term is A, and remember, arithmetic sequence is defined by the common difference, and the common difference is D. Then the number of terms is given as n. Then for us to find the sum of terms in that AP, then the sum of n terms in that AP or arithmetic sequence is given by s of n into raised equals to n over 2 into brackets 2a plus into bracket n minus 1 into brackets d. So that is the formula we are going to use to find the sum of terms in an arithmetic progression. Sometimes you can be given an arithmetic sequence whereby you have been told the first term is A, the last term is L, and the number of terms is N. So when you're given the first term and the last term, then for us to find the sum of n terms of that arithmetic sequence, arithmetic progression, it is going to be given by s of n equals to n over 2 into brackets a plus l, where a is the first term and l is the last term, and n is the number of terms. So n can be 20 if you are told 20 terms, n can be 15 if you are told 15 terms, 10 if you are told 10 terms, 7 if you are told 7 terms. So these two formulas of ours, we are going to preserve them and we'll use them later and we clear. So we preserve, then clear. Then you look at a question. Now, question goes, in an arithmetic series of 1, 5, 9, 13, find the sum of the first 20 terms. Find the sum of the first 20 terms. Now, from here we can establish that the first term is A, which is equals to 1. So you can say the first term is 1. We can also establish that the common difference between 1 and 5 is 4. Between 5 and 9 it is also 4. Between 9 and 13 it is also 4. Then you have been told to find the sum of the first 20 terms. So the value of n is 20. So using our formula, we will equate these values inside, which translates to this one. And solving this one or simplifying gives us 10 into brackets 2 plus 19 times 4, which simplifies down to 10 into brackets 2 plus 76. 2 plus 76 is 78. So this one simplifies to 10 multiplied by 78. So the sum of the first 20 terms is equal to 780. 780. Going ahead to look at part B, we can see that in part B, the value of A is 1, the value of D is 4, the value of N is 100, because it's the sum of the first 100 terms. So equating it in our formula that we have here, this one equate inside, it gives us this one. Then if you simplify, you'll get 50 into brackets 2 plus 99 times 4, close the bracket, which simplifies down to 50 into bracket 2 plus 396. 396 plus 2 is 398. So this one is 50 multiplied by 398, which gives us 19,900. So the sum of the first 100 terms is 19,900 of this arithmetic sequence or series, that is 1, 5, 9, 13. Now we'll also clear this one and look at another question also. So when you're clear, you look at second question, which says the sum of the first 10 terms of an AP is 400. So if the sum of the first 6 terms is 120, find the sum of the first 15 terms. Now, we know very well that the sum of n terms is given by this formula. So the sum of the first 10 terms is 400. So S of n is 400 and n is 10. So you equate it in the formula, you end up with this one, which simplifies down to this one. And this one can be simplified further into 400 equals to 10a plus 45d. So this one, we call it question 1. They have also said that the sum of the first 6 terms is 120. So the value of n is 6 and the value of S of n, Sn, that is S subscript n, is 120. So simplify, and this one translates to 120 equals to 3 into brackets 2a plus 5d, which simplifies down to 120 equals to 6a plus 15d. So you call this one equation 2. So equation 1 and equation 2 are two simultaneous equations which can be solved simultaneously with any of the available methods of solving simultaneous equations. When you solve equation 1 and 2 simultaneously, then the value of a is negative 5, that is the first term, and the value of d is 10. So now that we found the value of a is negative 5 and the value of d is 10, we can go ahead and find the sum of the first 15 terms. We know that that is the formula for finding the sum of n terms of an arithmetic progression. So equating the value of 15, that is n equals to 15, a equals negative 5, and d equals to 10, translates to this one. So the sum of the first 15 terms is going to be 975. 975. So we'll also clear this one out. After clearing, we'll look at the next question. And the next question says, the sum of the first 10 terms of an AP is 7.5. If the third term of the series is 2, find the sum of the first 13 terms. Now, we know that to find the sum of n terms of an AP, we use this formula. Now, equating the value of n equals to 10, we've also been told the sum is 7.5. So equating the values of n and s of Sn, so you have that 7.5 equals to 10 over 2 into brackets 2a plus into bracket 10 minus 1d. Because the value of n is 10 and the value of sum of n terms is 7.5. So, solving this one, we'll get 7.5 equals to 5 into brackets 2a plus 9d, which simplifies to 7.5 equals to 10a plus 45d. And this one, we call it equation 1. Now, you've also been told that the third term of the series is 2. Since it is an arithmetic sequence, an arithmetic progression, we know that for us to find the nth value, it is going to be a plus n minus 1 into brackets d. So, the value of a, in this particular case, we don't have, but we have the value of n, which is the third term. So, the third term is 2, which equals to a plus into bracket 3 minus 1 d, which simplifies to 2 equals to a plus 2d. So you can call this one equation 2. Now, equation 1 and equation 2 are two simultaneous equations. So you solve equation 1 and 2 simultaneously and find that the value of a is going to be, the value of d is going to be negative 0.5 and the value of a is 3. So from one value to the next value, consecutive value, there is a difference of 0.5. You add negative 0.5. That means you subtract 0.5 from one value to the next value. So this one looks like a decreasing sequence. Now, you are supposed to find the sum of the first 13 terms. So using our formula, equate the value of d, equate the value of n, and also equate the value of a. N in this case is 13. So if we equate, you have this one. And when you solve, you have that the sum of the first 13 terms of the series is going to be 0. So that's how we tackle questions on arithmetic series, that the sum of terms in an arithmetic sequence. Thank you for watching and learning. You can like and subscribe to my social media handles: YouTube Ombisi Online Mathematics, then Facebook Ombisi Online Math. Thank you very much.